So let's do a review. First off, if you ask me to find the exact value, I know I'm going to be using the hand tool. So to find the exact value of the sine of negative 225, we know first, we're going to find the reference angle. Second, we're going to find out is it plus or minus. And then third, we're going to find out, we're going to evaluate that reference angle. So if I draw my picture and I go back negative 90, and then I go back negative 180, go back just, if I was to go all the way here, that'd be negative 270, so that's so too far. So I'm over, somewhere over here is going to be my negative 225 degrees. So my reference angle, if I go back to the x-axis, is 45 degrees. So that means that my reference angle is going to be over here with an angle of 45 degrees in the first quadrant. My reference angle is 45. Now, is the terminal side of my angle over here, is sine going to be positive or negative in this quadrant? On this quadrant, x is negative and y is positive, so I know my answer is going to be positive something. Okay, so it's positive. Then evaluate. Well, if I evaluate 45 degrees, if you look at trig hand, it's going to be thumb, finger, nubbin, finger, finger. And then if it's 45 degrees, we know it's cosine over sine. So sine is on the bottom, so it's going to be square root of 2 fingers over 2. For cotangent, again, I'm going to do the same thing every time. I'm going to find my reference angle. I am going to, for step 2, I'm going to find out is it plus or minus. And then step 3, I'm going to say, evaluate that reference angle up here. All right. So first, I need to look at 4 pi over 3. If you open up this far, that's pi, but I'm going to think about it as 3 pi over 3. If I went all the way here, that would be 2 pi, but I'm going to think about that as 6 pi over 3. So halfway in between 6 and 3, right here, is going to be 4.5 pi over 3. So that means my 4 pi over 3 is somewhere over here. There's my 4 pi over 3. And so my reference angle is going to be pi over 3. Okay, so that means my reference angle is pi over 3, so I'm over here. All right, so reference angle is pi over 3, otherwise known as 60. Then in this quadrant where my terminal side lives, I know that x is negative and y is also negative. So I know that my cotangent, which is going to be the, what is it? It's the cosine of 4 pi over 3 divided by the sine of 4 pi over 3. I know that the cosine is going to be negative and the sine is going to be negative. So in other words, my answer is going to be positive. Then when I do my evaluating, so I found my signs were both negative, and it means the answer is going to turn out to be positive in the end. But now I'm going to evaluate my pi over 3, which is going to be this, 1, 2, 3. And so cosines on top, sines on bottom. So the square root of 1 finger over 2, cosine is 1/2. And sine, the square root of 3 fingers over 2, is going to be sine. So how do you take one thing and divide it by another? Well, you multiply by the reciprocal. These cancel out, and I get 1 over the square root of 3. But then I want to rationalize the denominator, so I hit it with the square root of 3 over 3. So that would be my answer. All right, 2 angles in radians, one positive, one negative, that are coterminal. So if we're going to do coterminal, I can do theta plus 2 pi, or I can do theta minus 2 pi. So you want to add one wasted revolution. So if I have negative 5 pi over 6 and I add 2 pi, I'm going to get this plus, well, I'm going to hit that 2 pi with a 6 over 6 and get 12 pi over 6. So now if I add, this is the same as adding a wasted revolution. And so when I add that to my already negative 5 pi over 6, I'm going to get 7 pi's over 6. So that is going to be coterminal to my original. Now I take my angle, which is negative 5 pi over 6, and I subtract a revolution. I'm going to get negative 5 pi over 6 minus, and I'm going to hit this with 6 over 6, a nice, well-chosen one. I'm going to make a good choice and get 12 pi over 6. So now that they have the same denominators, I get negative 17 pi over 6. Negative 17 pi over 6, right? Hey, how are you? Oh, you can come in here if you need to. Go ahead. I'm just going to be talking the whole time. So you can turn on lights, do whatever you need to. So to determine two angles, one complementary and one supplementary, well, if we're thinking about complementary, we're thinking about 90 minus. If we're thinking about supplementary, we're thinking about 180 minus. So if I take 90 minus my 31.1, then I'm just going to add up. So if I add 0.9, I get 32, 8, I get 40, and then 50 would get me to 90. So this is going to be 58.9. If I take 180 minus 31.1, again, I'm going to add up. So I take 0.1 and add 0.9 to get to 32, 8 to get to 40, and 140 added to 40 gets me where I want. So this is 148.9. Okay. Find an angle in radians where this happens. Well, first thing, I know cosine is negative, so that means it's either in this quadrant or this quadrant. But then they tell me, hey, you have to be in the third quadrant, so I know I'm somewhere down here. So I draw my radius first. That way I always get my triangle correct. It's always a radius and then go to the x-axis. So there's my triangle. Excuse me, I know that cosine is negative square root of 2 over 2. That means I have some reference angle over here where the x-coordinate is the square root of 2 over 2 comma something, because cosine is x. So when do I get a cosine of the square root of 2 over 2? Well, if you think about your trig hand, cosine over sine, the square root of 2 over 2 would be pi over 4, right? So pi over 4 must have been the angle in the first quadrant that gets you square root of 2 over 2. That means if we come over here to the third quadrant, the angle is going to end up having a reference angle of pi over 4. So if this is pi, which is the same as 4 pi over 4, and you add the reference angle of pi over 4, you're going to end up getting 5 pi over 4. Okay. Then converting degrees to radians, we know we're just going to use a well-chosen one. And so I could multiply it by pi over 180, or 180 over pi. Which one is it? Well, we want to remove degrees, so we'll put 180 on the bottom. But again, this is still a well-chosen one. So now when you multiply it, you get 65 pi over 180, yes. And then you just simplify that fraction. And I'll let you do that. Over here, if we got a circle of radius, and this is the central angle, the main thing to know here is that theta must be in radians. And theta must be in radians, so what does that mean? If theta must be in radians, then S is equal to R, which is 8. In radians, if you take 140 times pi over 180, well, notice what happens. That's going to be what our angle is. The degrees cancel out, and you get 140 pi over 180. Well, you can divide them both by 10 and get 14 pi over 18. Divide them both by 2, and you get 7 pi over 9. So that's the theta you put in here. 7 pi over 9. So we get 56 pi over 9, that many inches. And that's your answer. Area of a sector, if its radius is this and central angle is this, well, again, theta must be in radians. If it's not, so in this case, we get 1/2. The radius is 6 squared. Theta is 5 pi over 4. And so you're good to go. You just have to simplify. So that's 1/2 times 36 times 5 pi over 4. So that's going to give us 36 times 5 times pi over 2 times 4. And then we just start simplifying. You take a 4 out of these and leave a 9 on top, right? So that's just 45 pi over 2. Well, notice if it's in inches, and we plugged in inches here before we squared it, then the units are going to be square inches. All right. The measures of A. So it says find the measure of A and the sides CB and AB, right? But that's the same as BC, right? So BC and AB. Okay, let's find them. So if this is a right angle and this is 64, well then we know that 64 plus angle A must multiply together to be 90, because 90 plus these two must add to 180. So when I subtract, I get that angle A must be, well, 6 gets to 70, and 20 gets us to 90, so that's 26. So then if I want to find AB, I just think of it in terms of what I want, AB, and the other things that I know, 7 and 64. So for this one, this AB would be the hypotenuse. This would be opposite of 64, and BC would be adjacent, right? Okay, so if I want to know what AB is, then if I take 64, 7, and AB, I guess what is opposite over hypotenuse? Well, that's sine. So the sine of my 64 degrees must be equal to the opposite, which is 7, over the hypotenuse, which is what I want AB. So now all you have to do is solve for AB. Well, how do you do that? Let's multiply both sides by AB to get rid of that AB in the denominator. Right? These cancel out, and you get 7 is equal to AB times the sine of 64. So then you just divide both sides by the sine of 64. So you get that AB is 7 divided by the sine of 64. So AB is 7 divided by the sine of 64, and that's how you can leave your answer. BC, well, let's think about what that is. If we're thinking about BC, well, now what we're thinking is, I want to relate BC to this angle and the 7. So we're wanting to relate an angle to its adjacent and its opposite. Well, we know that opposite over adjacent is equal to the tangent, right? So the tangent of 64 degrees is equal to the opposite, which is 7, over the adjacent, which is BC. So again, to get rid of BC, I multiply both sides by BC. Stuff cancels, and I get 7 BC is tan of 64. Then divide both sides by that number, the tangent of 64. And that's what BC would be. And that's how you leave your answer. 7 divided by the tangent of 64. All right. Now, angle in standard position passes through the terminal side, what? -3 on the x, 7 on the y. So x is equal to -3, y is equal to 7. Find cosine and tangent. Well, let's find cosine and tangent. Well, I know if I want to find cosine of theta is x over r, because we're not in a unit circle. So not unit circle. Put my little warning symbol. Warning, not unit circle. So that means r does not equal to 1. You have to do some work. So cosine is x over r, and tangent is y over x. So I think if I can find x, y, and r, I'm good to go. Well, here I know x and y, because they gave them to me. I just need to find r. And how do you do that? Well, we tell the reader I'm going to find r by using x squared plus y squared is equal to r squared. So x squared is negative 3 squared, y squared is 7, and r squared is I don't know. So this is 49 plus 9 is equal to r squared. So 58 is r squared. That means r is plus or minus 58. And we know that because the radius is always positive, we just take the positive value. So r is the square root of 58.